Hello and welcome to the course on basic electrical circuits. My name is Ankush Sharma. I am working with the Department of Electrical Engineering at IIT Kanpur. In addition to the academic experience which I have got in IITs, I also have experience in IT industry for around 18 years. So, today we will discuss about some core concept of the basic electrical circuit. I will try to understand why this particular subject is required. So, before going into the detail, first question you may be asking that why you want to study this particular subject. So, although the electricity and magnetism was known to mankind since ages, but the technical aspect, or we can say the conceptual scheme of that electricity and magnetism was not developed until 19th century. So, basically when the scientists like Volta and Galvani developed the concept of getting electricity generated from the chemical processes, the fundamentals of electricity came into the picture. Other scientists like Henry gave the concept of electricity induction, and then later on in the 19th century at around 1873, the concept of Maxwell equation came out, which was the compilation of all the previous works related to electricity and magnetism, and then we can say that the conceptual scheme of the concepts came out. Now, if you see the electricity and magnetism equations of Maxwell, they are mostly talking about the electric field, and if you cross verify the commercial interest, they are more into voltage and current. So, that is why we were interested into another phenomena called basic electrical circuits. There we are more interested in about analyzing the voltage and current than the electric field. So, in this particular course we will try to understand the basic circuits and try to analyze what is the phenomena like electricity and magnetism and its relationship with the voltage and current. So, we will go through the course content. First week we will go with the basic circuit elements and waveform, and then week 2 we will devote on mesh and node analysis. Since we know that the network theorems are very important aspect of the circuit theory, we will devote next 2 weeks on network theorems. Then first order and second order networks will be discussed. The Laplace transform and its application will be discussed in the 6th week. 7th week we will devote on circuit analysis using Laplace transform. Then on week 8 we will talk about the 2-port network, and since sinusoidal is also one of the important element in our electric concept, we will devote at least 2 weeks on sinusoidal steady state analysis. Then we will see the relationship between electricity and the other type of systems. So, we will establish the analogy between the electricity and other analogous systems, and finally, we will talk about the state variable analysis. The reference books which you can follow are like Fundamentals of Electric Circuits by Charles Alexander and Matthew Sadiku. Then you can also follow Network Analysis by Van Valkenburg and Network and Systems by D. Rai Chaudhary. Now, in this session we will talk more about the basic concepts of electric circuits. So, what are those concepts? Let us talk about first the electric circuit. So, electric circuit is nothing but an interconnection of electrical elements. You can think of like a flashlight where you have only one voltage source, then the lamp and the wires. So, it is like a simple electrical circuit, but in reality you will not see simple circuits, rather you will see lot of complex circuits having multiple components of the sources as well as wires. So, what we will study in this course, we will try to analyze the circuit by studying the behavior of the circuit. Why we want to study the behavior? Because we want to understand how does it respond to a given input. So, you can see that when you give input to a particular network, it will respond in based on the input which we have provided. So, we have to somehow try to stabilize the relationship between input and response, and then we will see how the various elements in the circuit will interact. Now, let us talk about the charge. What is charge? Charge is an electrical property of atomic particle of which matter consists. So, if you see anything around you, you will see it is composed of molecules, and then molecules are composed of atoms. Inside the atom you will see electron, proton and neutrons. So, basically each atom will consist of three major elements, that are electron, proton and neutrons. So, electric charge is most basic quantity of circuit required to explain all electrical phenomena. You know that the electron is negative charge particle, while the proton is positive charge particle. So, the electron will have a charge equal to 1.602 into 10 to the power 19 coulomb, because electric charge is measured in the parameter called coulomb. Now, proton is on the other hand positively charged, and it will have the same magnitude as of electron, but that is plus sign with 1.602 into 10 to the power 19. Now, if you are asked to find out how many electrons would be there in 1 coulomb of charge, you will simply divide 1.602 into 10 to the power 19 by 1, you will come to you will get the number of electrons which would be there in 1 coulomb of charge. So, the output would be 6.24 into 10 to the power 18 electrons. Now, the electric charge follows the law of conservation, which states that charge neither can be created nor can be destroyed. Now, let us talk about the electric current, because electric current is derived from the charge which are flowing in a particular element. Here battery will act as a source of electromotive force, that is simply called as EMF. Now, when you are connecting a conducting wire to a battery, it will cause electron to move in one particular direction. This motion of charge creates the phenomena called electric current. Although current in a metallic conductor is due to flow of electrons, but conventionally it is taken as current at net flow of positive charge. So, if you see the figure, you will see that the flow of current is opposite to the direction of the flow of electrons. So, that is the convention we follow when we define the electric current. Now, since electric current can be defined as a time rate of change of charge, you can simply define it as I is equal to dq by dt. So, it means that the amount of charge is flowing across a particular surface in a unit time. So, how you will define the current? Current is defined in the form of amperes, and 1 ampere is defined as 1 coulomb per second. Now, if you are asked to find out how much charge is transferred between time t naught to t in a particular surface, you can simply evaluate by integrating the above equation. So, you will get q is nothing but the integration between t naught to t multiplied by I times dt. Now, let us take few examples so that you can better understand the concept. Let us take one example, like how much charge is represented by 4600 electrons. Now, since you know that the charge of one electron is minus 1.602 into 10 to the power 19. So, for 4600 electrons the total charge would be simply multiply 4600 by 1.602 into 10 to the power 19. So, you will get minus 7.369 into 10 to the power minus 16 coulomb. Now, opposite to that, if you are asked to find out how much charge is being represented by 6 million protons, then you have to be very careful, because the proton will have charge positive of 1.602 into 10 to the power 19, which is quite opposite to the electron, because in electron you will see charge as minus 1.602 into 10 to the power 19. So, proton will be opposite, that is positive of 1.602 into 10 to the power 19. Now, for 6 million protons, multiply 1.602 into 10 to the power 19, that is the coulomb charge per proton, multiplied by 6 into 10 to the power 6. So, you will get 9.612 into 10 to the power minus 13 coulomb. Now, let us take another example. If the total charge entering a terminal is given by some expression like q is equal to 5 t sin 4 pi t millicoulomb, how you will calculate the current? So, what you have to do, since you know that the current I is nothing but dq by dt, you have to simply differentiate the q with respect to time t. So, you will get d by dt of 5 t sin 4 pi t. So, that is simply 5 sin 4 pi t plus 20 pi t cos 4 pi t, that is the derivative of the coulomb charge which was given in the question. Now, we have to calculate current at time t is equal to 0.5 second. That means, whatever the current value I you have got, you have to simply multiply by wherever you have time t, you have to just simply replace with 0.5 and solve the expressions. So, here you will get current I as is equal to 31.42 milliampere. Now, instead of charge, if current is given, that is, say in this example we are seeing that I is equal to 3 t square minus t ampere, and now you are asked to find out the total charge entering in a electrical terminal between time t is equal to 1 second to t is equal to 2 second. How you will calculate? You have to just simply integrate the current value between time t is equal to 1 to t is equal to 2. So, if you solve by putting the value of I is nothing but 3 t square minus t, then multiplied by dt and solve, you will get the amount of charge entering in a terminal between time 1 second to 2 second, and that is 5.5 coulomb in this particular case. Now, let us talk about voltage. Now, energy transfer or work is needed to move electrons in a particular direction. So, who will provide this energy? This energy is supplied by the external supplied through the external EMF, that is provided by the battery. So, battery will work on the electrons to move from one side to other side, and this EMF is also known as voltage or potential difference. Now, how you will define the voltage? Voltage will be defined as the energy required to move a unit charge through an element. So, that is simply, if you see this figure, the element is represented here, and now you have two terminals, one is positive, another is negative. One terminal is given as A, another is B. So, potential difference, that is voltage, is given as VAB. Now, you need to find out the value of VAB. What you will do? You will try to find out the work done by battery which is connected external to this element. right, to move 1 unit charge from point A to point B. So, how you will express in mathematical terms? You will simply say VAB is nothing but dW by dQ, that is work done divided by the unit charge or the differential charge in this case, that is why we are representing as dQ. Now, VAB we simply say as volt, energy we simply give in the form of joules, and Q is the charge which we generally present in the form of coulombs. Now, how you will measure 1 volt? 1 volt is nothing but 1 joule per coulomb, that is nothing but 1 Newton meter per coulomb, because 1 joule is nothing but 1 Newton meter. Now, positive and negative sign has its own importance, because when you change the sign you will simply get opposite of VAB. So, you can simply say, if you replace in the previous figure plus with minus sign, minus with plus sign, VAB will be opposite of what we have calculated in this particular case. Now, if you do not want to represent in this form, simply you want to represent in the form of VBA, that is opposite of that. How you will represent? You will simply say VAB is nothing but minus of VBA. So, basically you are as interchanging the terminals of the element, and you eventually get the negative of what we have shown in the previous figure. So, in the circuit theory we generally represent the answers in the form of voltage and current until unless it is specified, because these are the two basic elements in our electric circuit. Now, it is not that we always go with voltage and current as an output, we sometimes need power and energy also as an output. So, what we have to do for practical purpose, we need to know how much power an electric device can handle, because when you pay your electricity bill, you pay electricity bill in the form of how many units you have consumed. Units means the 1 unit is in the form of 1 kilowatt hour. 1 kilowatt means the power multiplied by the duration for which you consume the electricity. So, it means that you need sometimes the power calculation to find out how much power you have consumed at that particular instant, and then when you will multiply it with the time duration, you will come to know how much energy you have consumed. So, that is why for our day to day electricity bill calculation, you need calculation of power as well as energy. So, the power and energy is also important portion for our circuit analysis. Now, let us try to find out how to calculate the power and energy, because these are derived from voltage and current. So, how we will calculate? Power is nothing but time rate of expending or absorbing the energy. So, in mathematical terms we can represent it like P is equal to dW by dt, that is rate of change of energy. Power is measured in watts and W, that is the energy, is measured in joules. Now, if you want to find out the value of power P in the form of two basic quantities which we discussed previously, that is voltage and current, how you will find out the value of power P? You just see the expression P is nothing but dW by dt. Now, if you express dW by dt as dW by dQ and dQ by dt, you will simply get the expression for power P in the form of voltage and current. How? dW by dQ is nothing but the voltage which we discussed in the previous class, previous slides, and I is nothing but rate of change of charge passing through a particular element. So, with this you can simply calculate the value of P as a multiplication of voltage and current. So, by this you can find out how much power is being absorbed or supplied by an element, because it is a product of voltage across the element and current passing through that particular element. But you have to keep in mind that this power P is a time varying quantity and is called a instantaneous power. So, when we will discuss in detail the sinusoidal waveforms, we will try to stabilize the difference between instantaneous power and average power, because that is also the important concept which is more important for AC currents rather than DC currents, because in DC currents you can simply say that power P is nothing but a product of voltage and current, but in AC it does not, for at least for average power it does not follow like this. Instantaneous power, it will be definitely a product of instantaneous voltage and instantaneous current. Now, the power has positive sign, it means that power is being delivered to or absorbed by the element. So, now look at this particular figure. If the current is flowing inside the element, then the inside the element through the positive terminal, you will say that power is being absorbed by that particular element. But if the current is coming out of the positive element, the power is being supplied by that element. That is why the negative sign is coming in this expression. Now, suppose if we say that the current is coming from this side, it means that if current is flowing like this, it will come via this. So, what will happen if you alternatively if you say that if current is coming out from the negative terminal, then also the power term will be positive. It means that power is being consumed by the element. While in the case of other figure, if current is going inside the terminal, that is negative terminal, you will again get the power as negative. It means that the power is being supplied by the element. So, if you see the equivalent diagram of a battery, you will generally say that the battery supplies current through its positive terminal and comes via negative terminal. So, if you just connect the resistance, you will come to know that the current is flowing in this direction. It means that positive power is being supplied by the battery and positive then power is being absorbed by the element. So, the sign convention is very important to understand, because if you make a mistake in representing the signs properly, you will do some mistake in calculating the value of power. Now, the voltage polarity and current direction should conform to those shown in the previous figure. So, what we represent this particular sign convention, this sign convention is considered as a passive sign convention. It is satisfied when current enters through the positive terminal of any element, the power consumption is positive, and when current enters through the negative terminal, then power P is negative of Vi, that means power is being supplied by the element. Now, this particular aspect will follow the law of conservation. It means that one should supply the power, other should consume the power, and for this reason your algebraic sum of power in a circuit will always be 0. Now, suppose if you are asked to find out the value of energy absorbed or supplied by an element from time t0 to time t, how you will calculate? You have to just simply integrate the power with respect to time between t0 to t, and you will get the value of energy supplied or absorbed by the element based on the convention which we discussed in the previous slide. So, what is energy? Energy is nothing but the capacity to do some work and is measured in joules. Now, let us take example so that you can better understand the concept of power and energy. Suppose the question is given like this: an energy source forces a constant current of 2 ampere for 10 seconds to flow through a light bulb. If 2.3 kilojoule is given off in the form of light and heat energy, what is the voltage drop across the bulb? Now, what is given? You have got current I, you have got time delta t, and now you have also got the value of energy which has been consumed. So, first what you have to do? You have to recollect what is the expression for voltage, that is nothing but change of energy with respect to charges flowing from through that particular element. Now, this particular quantity is given in this question, you need to find out the value of delta q. Delta q is nothing but the product of current and time. Time is given as 10 second, current which is flowing through an element is 2 ampere. It means that 20 coulomb of charge is being transferred from through the element, and now using this value you can simply calculate the value of voltage drop across the element. So, in this case the element is light bulb. So, voltage drop across the light bulb would come out to be around 115 volt. Now, let us take another example. If you are asked to find the power delivered to an element at time t is equal to 3 millisecond, if the current entering its positive element is I is equal to 5 cos 60 pi t ampere and the voltage V is 3 I. So, 3 I means the voltage is depending upon the current. So, what you have to do? You have to first find out the expression for voltage. So, voltage is nothing but 3 I, that is 3 multiplied by the value of current I, that comes out to be 15 cos 60 pi t. Now, you need to find out the value of power P, that is V into I. So, that comes out to be 75 cos square 60 pi t, because V you have got, current you can see from here, if you multiply you will get 75 cos square 60 pi t watt. Now, you need to find out the power delivered to an element at time t is equal to 3 millisecond. It means that you have to simply replace t with the value of 3 millisecond, and when you simplify you will get simply the power delivered to an element, that is 53.48 watt. Now, if in the previous problem, if voltage is given like 3 di by dt instead of 3 I and other things are same and time t is equal to again 3 millisecond, how you will calculate? Now, voltage value you have to find out by simply differentiating the value of current I. So, current I which we saw in the previous example was 5 cos 60 pi t. So, if you differentiate you will get minus 60 pi into 5 sin 60 pi t, and with this you will get the value of voltage V as minus 900 pi sin 60 pi t. Hence, the power P can be represented as V into I. You have to simply multiply voltage V with the current expression which we got in the previous example. We will get P is equal to this expression, that is minus 4500 sin 60 pi t cos 60 pi t, that is in watts. Now, For time t is equal to 3 millisecond, you have to simply replace t with 3 millisecond and simplify the expression, you will get the value minus 6.396 kilowatt. Now, let us try to understand what are the various circuit elements in the electrical circuit you will see. So, there are basically two types of elements which you will see, one is passive element, another is active element. So, active element is what? The element which is capable of generating energy, while the passive element does not generate the energy. So, what are those passive elements? These are resistors, capacitors and inductors. And what are the active elements? Active elements are like generators, batteries and operational amplifiers. So, what are the most important active elements for our circuit analysis? The most important are voltage and current sources, because generally when you will solve any electrical circuit, you will generally see that voltage and current are given as a source for the supply of power. Now, you will see there are two different kinds of sources, one is independent, another is dependent. So, if we see the ideal condition, in ideal condition the ideal independent source will provide a specific voltage or current that is completely independent of other circuit elements. In this case, the ideal independent voltage source delivers to circuit the whatever current is necessary to maintain its terminal voltage, because in case of ideal voltage source, your terminal voltage will always remain constant and it will supply power which is necessary to satisfy the power balance equation in the circuit. Now, physical sources such as battery may be regarded as approximation to the ideal voltage sources, although those are not ideal voltage sources, because battery has its own losses. So, because of that, when you keep on supplying power from the battery, after some time the terminal voltage will go down, but for a practical purpose we can consider battery as an ideal voltage source. So, ideal dependent source, if you are talking about, it means that the source quantity is controlled by another voltage or current. It means that when you see the particular source, that is dependent voltage source or dependent current source, its value is derived from the output of any other element. That may be like if the circuit element has a resistance, the voltage drop across resistance will derive the value of voltage source. So, how you will see those sources in the circuit? There are certain symbols specified for those sources. Say in case of independent sources, you will see this is the general convention followed for ideal voltage source, that is DC voltage source. Ideal current source is represented by this symbol. When you see the dependent sources, you will see voltage is represented like this. It means that you will see the square as a representation, while in case of ideal you will see the circle. Similarly, in case of current you will see square as a dependent current source, and in case of ideal current source it will be circle. So, with this you can differentiate whether in the circuit there is a independent voltage or current source or a dependent voltage and current source. So, I think with this we can conclude the today's session. In next session we will discuss more about the other elements. Thank you.